This is for Year 12 Specialists. It comes out of MAV 2015. So it's an old paper. And it's exam 1. It's about projectiles. Now, projectiles aren't specifically stated in the study design, but they weren't stated in the documents about being removed. But I've only seen a trial exam where there was a projectile question. Whenever you're looking for direction and the angle that the jet lands, it's the velocity that will tell us direction. So its position vector is of no use to us about direction. So r dot will equal 60 in the I minus 80 in the J minus 8 in the K. And that's going to tell you its velocity. And as you can see, the velocity doesn't change for the whole time because it's not in respect to t, because there's no t's in it. So what have we got here? We've got a jet, and the jet takes off and lands, and when it lands there's an angle, and that theta is what the question's being asked about, and it's the tan of theta. We have an I, we have a J, and we have a K, and the K is vertically up and down. So what have we got happening? I might have an I component and I might have a J component, and they're both on the ground, and then I have a K component. So my projectile is going to land, and let's say it lands there. What I need to do is I need to work out the horizontal and use my K value as being the vertical. And I know in this particular case the K is over here at -8, because I can see there the K of -8. And I've gone 60 in the I, and I've gone 80 in the J, even if it's negative. So when it lands, this is going to be my angle here, which is going to be sitting in three-dimensional space, and that's going to be a right angle. So this length in here is going to be 100, because 60 squared plus 80 squared is going to be equal to 100 squared, because it's a 3, 4, 5 triad, or a 6, 8, 10, or a 60, 80, 100. So that's 100 and that's 8. So the tan of theta is going to be 8 on 100, which is going to be 2 on 25. Now, I don't believe we're going to have projectile questions in November. But if we did have, it's the velocity vector that I consider for direction. And at point of landing, I was just wanting to isolate that point when it landed. I'd have to find the time that it landed. However, there was no t's in any of these to know what time it landed. If I was asked what time it landed, I know that it would land when the K component is equal to 0, because it means that the vertical component, the up and down component, is 0. So I know that at 260 on 8 is going to be the time that it lands.